So let us understand what is the meaning of this segmental stimulation. So the importance, see, first of all, what is segmental stimulation? Segmental stimulation, this is a nerve conduction study technique in which we stimulate a nerve at shorter intervals, usually 1 centimeter apart, so that we can find out a focal site of conduction abnormality. So what's the purpose of segmental stimulation? Here the main purpose is to precisely localize focal nerve lesions, especially focal demyelination or entrapment neuropathies. Why does normal routine NCS fail to detect this focal lesion? The problem with the routine NCS is it the conduction is measured over a long nerve segment. So, if only a small portion of that segment is abnormal, the normal portion dilutes the effect of focal slowing. So, the small portion of the segment is abnormal, so the normal portion will dilute the effect of focal slowing. So, more chances that we will miss the focal lesion. So, what do we do here that helps us in overcoming this problem? Here we do the inching method. So how does this inching method overcomes the problem? Instead of measuring conduction over a long segment, here we stimulate nerve at very short intervals. Commonly every 1 centimeter we stimulate the nerve. So this will allow us to exactly localize where the delay is. Why is it called inching if we are doing it at 1 centimeter? The stimulation site is moved very little by little along the nerve, usually 1 centimeter at a time. So it is ideally to be called as centimetering than inching. Let's take an example and let's understand it. Suppose a nerve conduction is done and normal nerve conduction is 50 meters per second. Uh, So 1 centimeter of the nerve segment will correspond to zero point 0.2 milliseconds. Therefore, 10 centimeter will correspond to 2 milliseconds. So now suppose a focal lesion is present and zero point 0.2 millisecond conduction delay is contributed because of this focal lesion. So uh, over 10 centimeters, the conduction used to take 2 milliseconds. But due to focal abnormality that will add zero point 0.2 milliseconds, the abnormal nerve conduction study shows 2.2 milliseconds. So that is only 10 percentage increase, which will not be considered as significant. But when you stimulate over 1 centimeter, the normal conduction is zero point 0.2 and abnormally it becomes 0.4. That's a 100% increase in the time. So, when you stimulate the nerve over 10 centimeter, the change is only 10 percentage. Whereas when you stimulate over 1 centimeter, the change is nearly 100 percentage. So it becomes more obvious when you stimulate it over short segment. So normally, how is the latency appear by doing inching method? The latency should increase gradually and approximately linearly as the stimulation site is moved proximally. So as we go proximal, the latency should increase gradually and approximately linearly it should increase. Example, if you increase by 1, 2, 3, 4 centimeters the stimulation, then the latency should be 0 0.2, 0 0.4, 0 0.6, 0 0.8. I mean to say there should not be any sudden jump. So A sudden disproportionate increase in the latency across one short segment, example zero point 0.2 millisecond, zero point 0.4, zero point 0.6 followed by 1.3. If it happens like that, then suggests that there is a lesion located at the particular short segment. See, something else can also accompany this increase in latency. That is the change in waveform morphology. When we come across the focal conduction delay, so even morphology changes. So what is the classical example we see for such a inching method is carpal tunnel syndrome. Here inching will help us localize the exact portion of the median nerve affected around the wrist joint. So what's the normal latency change occurring across the median nerve when it goes through the wrist? See, approximately 0.16 to 0.21 milliseconds per centimeter. This is what we see normally in a median nerve. So when moving the stimulus proximally 1 centimeter, the latency should increase by roughly 0.16 to 0.21 milliseconds. So what suggests a focal median neuropathy? If particular 1 centimeter segment shows much larger latency increase, that is for example zero point 0.7 to zero point 0.7 milliseconds or 1.1 milliseconds, when compared with the normal like 0.16 to 0.21 milliseconds, it strongly suggests there is a focal conduction abnormality that in that particular segment. So apart from carpal tunnel, where is this inching method particularly useful? See, it can also be used for ulnar neuropathy across the elbow, ulnar neuropathy across the wrist, and any other suspected focal demyelinating or entrapment lesions. So, how does routine NCS and inching method differ? In routine NCS, we measure the conduction over a very long segment. It helps in detecting generalized or significant abnormalities. Whereas in inching method, we measure conduction over very short segments, and it helps us in better precise localization of focal lesions. So you can remember it like this. Long segment nerve conduction study gives us presence of an abnormality. Inching tells us where the abnormality is. So long segment is for screening, short segment or inching is for localization. So that's how segmental stimulation or inching method is useful.